To wrap up the last part of this module on cryptology, let's discuss hashing passwords, rainbow tables, and salting. So a hash is just a unique number that gets produced from data. Further, changing just one piece of the data has a cascading effect. Okay, so why do we care about a hash? Well, on a website's database, you don't want to store the password. Rather, you want to store the hash of that password. That way, you type in your password and the system makes sure that after going through the hashing algorithm, it matches the hash on file. Let's take a look. On this website, you want to use the password 6. We'll be user 1, and if we push it through the hashing algorithm, it equals 2876. However, if we just change one thing like user 2 did with his last digit, it resolves into something completely different, 5699. And here you can see the results of user 3's password, completely unique. The hashing algorithm which is being utilized today is SHA-2, or the secure hashing algorithm. This is used often to validate all sorts of data, like a program. And by validating, again I mean we validate that the program is the original. Now MD5 is the old hashing algorithm and currently broken because collisions were found, meaning that more than one set of data can have the same hashed value. Again, if we are hashing a program to make sure that it is from the original author with MD5, we may be at risk. Risks including the injection of data, maybe a virus, which could infect your system. Now we have one more issue. People are using simple passwords, and we could pre-compute a lot of passwords hash and store it. This data store is called a rainbow table. And if we broke into the web server's database and found the hash values, we could use a rainbow table to find what that value equates to. In this case, 2876 equals password 6. So with the advent of the rainbow table, it degrades the value of using a password hash in this example. So to mitigate this, we use something called a salt value. Inputting a password and a salt value will create a unique hash. So to implement salting correctly, you really need to have a different random salt value for each user. Why? Well, let's examine two users with the same password, both with password 6 as a password, but with different salt values. Both hash values are different because the salt values are different. And if an attacker breaks into the database, stealing the random salt and hash values, the attacker won't be able to utilize a rainbow table.